going to use a graphing calculator to solve a logarithmic equation where we have a logarithmic expression on one side and we have a linear expression on the other side in this case. And what I'm going to do is I'm going to enter two functions into the graphing calculator, one of which is the left-hand side of the equation and the other of which is the right-hand side of the equation. So y1 is 2 log of 4 minus x, and y2 is simply 2 minus x. And then I hit graph. Okay, and I have two solutions here, one of which is an integer, or appears to be an integer, and it is the ordered pair 1, 1. And if I substitute that in, I need to check my functions. 2 log 4 minus x. That's not exactly right. So be careful about just looking in the looking at the graph and deciding which ordered pairs are. But if I put a 1 in the left-hand side of the equation, then I have 2 log base 10 of 3, which is actually slightly less than 1. And on the right-hand side of the equation, I have 2 minus 1, which is 1. So that ordered pair that looks like 1, 1 in this graph actually isn't. So now I hit intersect. If you're using a TI-83 or TI-84, that is second, and then the calc, C-A-L-C, which is in the top row of buttons right under the graphing window. And it'll give you the same options to find an intersection, to find a 0, all that kind of stuff. So I do want to find the intersection of y1 and y2, and I know that there is an intersection between 0 and 2. So it only asks me for 1. I think I'll change that to 1 because I know the solution is very close to 1. And then hit the intersect button. And as you can see, the x value here is 1.064, etc. I'm asked to round to the nearest hundred, so that solution is 1.064. And then enter a comma, and let's go find the next one. Let's do it new. And then I know there's an intersection somewhere between 3 and 4. So the option I'll put in here is just 4. And tell the calculator to guess. And it's actually at 3.886 to the nearest hundredth. Oops, I almost made a mistake there, didn't I? That's a bad reason to have Alex tell you you're wrong. And then this one is 3.89 rounded to the nearest 100th. Let's look at another example, see if it's significantly different from that. Okay, we'll do this one as well. So under y equals, I'm going to enter this function, use the e to the x that's on the keyboard, and then x here is actually the function or the linear expression 2x minus 3. And then for y2, I'll enter the right-hand side of the equation, x plus 1. And then I hit graph. And again, I show two solutions. So that looks suspiciously like -1, 0. But if I put a -1, in the left-hand side of the equation, that gives me e to the negative 5, which is not 0. So, again, don't go by your eyes. Hit the intersect button. I know that there's a 0 somewhere near negative 1. Or not a 0, there's an intersection somewhere near 0, 1. Rounded to the nearest hundred, that is negative 0.99. And then I want to find a new intersection, and I know that there's one somewhere near 2. And it's actually 2.06. And there you go.